Welcome back, students. Welcome to the session number 23 from the playlist of work, power and energy. The topic is the collision and the coefficient of restitution. And based on this topic, I have selected one question for this session, which is written here on this board. The question here is, three identical balls are lying on a smooth horizontal surface as shown in this figure. So this figure was already provided along with the question. Now, initially all the balls are stationary. Ball A is given a velocity of 10 meter per second, which collides with this ball B inelastically with the coefficient of restitution value of 0.5. So, ball B now collides with the ball C elastically, that is when the ball A is given a velocity of 10 meter per second. Let us say it is u1, so this is equal to 10 meter per second. So it will collide with the ball B after a certain period of time, and after collision this ball B will attain some velocity, and because of that this ball will again collide with the ball C. Now here the ball B is colliding with the ball C elastically. So the time interval between the two consecutive collisions of ball A and B is, there are four options here and we have to find the correct one. So let us first of all take the collision of the ball A and B. So here the ball A is given a velocity of 10 meter per second, and here I have taken this velocity as u1, and the initial velocity of the ball B is 0 because it is stationary, so I have taken it as u2 and this is equal to 0. So now the coefficient of restitution is given as E is equal to 0.5. Now the coefficient of restitution is basically the equation for E is equal to the velocity of separation of the colliding objects divided by the velocity of approach. And this is equal to 0.5 in this question. Now the let us say the velocity of the ball A after the collision is v1, and let us say the velocity of the ball B after the collision is v2. So the coefficient of restitution, that is E, will be equal to velocity of separation will be equal to what? Since here I have taken the velocity of the ball A after the collision is v1 and the velocity of the ball B after the collision is v2. So the velocity of separation will be equal to v2 minus v1 divided by the velocity of approach. Now the velocity of the approach will be equal to u1 minus 0. Now v2 minus v1, so this is equal to 0.5. So from this I am getting one relation, that is v2 minus v1 will be equal to, now u1 is equal to 10 meter per second, so 10 into 0.5 will be equal to 5. So this is the first equation which I have got with the help of the equation for the coefficient of restitution. Now in any collision, whether it is elastic or inelastic, we can apply the law of conservation of linear momentum. So in the collision of the ball A and B, I will be using the law of conservation of linear momentum. So the initial momentum will be equal to that is the total initial momentum will be equal to the total momentum after the collision. So the initial momentum will be equal to, since all these three balls are identical, so we can take the mass of each ball as m. Let us say the mass of each ball is equal to m. So if the mass of each ball is equal to m, then the total initial linear momentum before the collision will be equal to m, that is the mass of this ball A multiplied by its velocity, which is 10, plus the mass of this ball B, which is equal to m into 0, so this will be equal to 0, that will be equal to the mass of this ball A, that is m, multiplied by V1 plus the mass of the ball B multiplied by its velocity after the collision, that is V2. So from this equation I am getting V1 plus V2 is equal to, because here m will get cancelled out, so V1 plus V2 is equal to 10. So this is the second equation which I have got. The first equation was V2 minus V1 is equal to 5. Now V2 minus V1 was equal to 5. So this was the first equation which we have got by using the equation for the coefficient of restitution. So if I add both these two equations, I will be getting the value of V2 as, if I add these two, this V1 and V1 will get cancelled out, so 2V2 is equal to 15, or the V2 will be equal to 7.5 meter per second. So the velocity of the ball B in this direction, that is as indicated by this arrow, will be equal to 7.5 meter per second, and the velocity of the ball A. Now if I put the value of V2 as 7.5 in the equation number 2, I will be getting the value of V1 as 2.5 meter per second. So the velocity of the ball A after the collision will be equal to 2.5 meter per second. Now this ball, after the collision, this ball B is moving towards the ball C and it is colliding with the ball C elastically. Now in the elastic collision, so here first of all let me write the value of V2 as 7.5 meter per second and V1 is equal to 2.5 meter per second. Now this ball B is now colliding with the ball C elastically. Now in the case of elastic collision, the velocities of the colliding body, they interchange with each other. That is, the velocity of the ball C, which is stationary, is 0. So after in the case of elastic collision, the velocity of the ball B will become 0, because in the case of elastic collision, the velocities of the colliding bodies, they interchange. So the velocity of the ball B, this will be equal to 0, and the velocity of the ball C, this will be equal to 7.5 meter per second. Now if the velocity of the ball B is 0, then it means that it is going to stop at this point. It will stop at this point. Now here after the collision, at this point this ball A and B are colliding at this point. So at this point, after this point, the velocity of the ball A is 2.5 meter per second in this direction. That is, V1 is equal to 2.5 meter per second in this direction. So after colliding with the ball B at this point, the ball A will start moving with the velocity of 2.5 meter per second in this direction. And now here the velocity of the ball B after the collision is 7.5 meter per second, and after colliding with the ball C, it is going to stop here at this point C, and this ball C will move in the forward direction with a velocity of 7.5 meter per second. Now here this ball A will collide with the ball B, and the time taken for the next collision, time for the second collision, or you can say here the time interval between the two consecutive collisions between ball A and B. This will be equal to the distance traveled by this ball A divided by the velocity of the ball A after the collision. So the distance which the ball A has to travel in order to collide with the ball B, which will be stationed at this point C because of the elastic collision. Because in the case of elastic collision, the velocities of these two colliding balls will interchange. So this ball C will move forward with the velocity of 7.5 meter per second, and the ball V will come to rest at this point C. At this point, that is at the point where the ball C was stationed or it was present. So now this ball A will collide again with the ball B, and the time interval between the two consecutive collisions between the ball A and B will be equal to 10 divided by 2.5, where 2.5 is the velocity of the ball A after the collision. So this is equal to 4 seconds. Okay? So the time interval between the two consecutive collisions of the ball A and B is 4 seconds. That is the correct answer is the alternative A, which is equal to 4 seconds. So thank you very much for joining this session. In the next session, I will be continuing with the same topic, that is the collision. And in the next session, that in the session number 2, session number 24, I will be dealing, or I will be taking up a question which will be based on the elastic and the inelastic collision. So till then, have a nice day. Bye.